Coming soon, Psyche, a mission to explore a metal asteroid.
Three, two, one. Engine full power.
Welcome to Your Space Journey, where we venture into the future of space exploration. Your journey begins now.
Hello, thanks for joining me today for Your Space Journey. My name is Chuck, and today we're going to talk about the Psyche mission, a mission to explore a metal asteroid featuring Chief Engineer David O. In the vastness of space, there's a hidden treasure unlike any other, a relic of a violent past, a glimpse into the heart of a vanished world, a world that could have been our neighbor, but was torn apart by cosmic forces. A world that left behind a clue to one of the greatest mysteries of our solar system. How did planets form and evolve? This treasure is Psyche, an asteroid made mostly of metal orbiting the Sun between Mars and Jupiter. It is the only known object of its kind, and it may be the exposed core of a planetesimal, one of the building blocks of planets. Scientists believe that studying Psyche could reveal secrets about the origin and evolution of Earth's own core, and of the crashes, smashes, mergers, and acquisitions that shaped our solar neighborhood. But Psyche is not easy to reach. It lies in the main asteroid belt, a region of space filled with millions of rocky and icy bodies, some as large as mountains, some as small as grains of sand. To get there, a spacecraft must navigate through this chaotic swarm, avoiding collisions while enduring extreme temperatures and radiation. This is why NASA is sending Psyche, a daring mission to explore this unique metal world. Psyche will be the first spacecraft to visit a metallic asteroid and the first to use lasers to communicate with Earth. It will carry a suite of instruments to map, measure, and probe Psyche's surface and magnetic field, revealing its structure, composition, and history. Psyche is scheduled to launch in October 2023 and arrive at its destination in 2026. It will orbit Psyche for 21 months, collecting data and images that will transform our understanding of planetary cores and the early solar system.
Your Space Journey.
David, thank you so much for joining me.
Thank you. It's a pleasure to be here.
Well, it's an honor to have you. I bet you're excited. Here we are. Psyche is not too long before we're going to launch here. You've been working on this thing for years. How's it feel? You getting excited?
Oh, I am ready. We are in the home stretch and just under 70 days, right around 70 days until launch. And like you said, I've been working on this mission for over 10 years. So it is great to see it get to the pad.
Yes, it will. Now, tell me a little bit more about this. So you're the chief engineer for this mission. Tell me more about your role with Psyche.
Yes, I'm one of several chief engineers for the mission. I have been with the Psyche project since almost its very beginning. I joined it in 2013. And at the time I joined as essentially the proposal lead, what they call the capture lead, because we have to go through a competed process, propose a mission to NASA, compete with other projects for the money and whatnot. Right. So we came up with this concept working with the PI, Dr. Lindy Elkins-Tanton at ASU, to go visit a metal asteroid. And I had the pleasure of being involved in that all the way from the beginning when it was just a set of ideas on a whiteboard to what we have today, which is a fully assembled spacecraft. And along the way, I was a capture lead, and then a lead system engineer, and now I'm a chief engineer preparing for operation of the spacecraft.
Wow, what fantastic roles you've had, and to be there from the beginning, I couldn't imagine. And you mentioned this, I know Psyche is a metal asteroid, but there's a lot of people out there that might not know, what is a metal asteroid? What's so special about Psyche?
So Psyche is the largest metal asteroid in the solar system. It's about 150 miles in diameter, 225 kilometers, and it is made at least, scientists believe, 50% of metal, iron, nickel ore. So way more metal than you have in a normal planet, way more metal than you have in normal asteroids. And that makes it a world unlike any we've visited before. We've visited worlds made of gas and the gas giants. We've visited worlds made of ice like Pluto and rock like Mars, but we've never visited a world made primarily of metal. And so this is our first chance to go see what a metal world might actually look like. And I think that makes this an exciting mission.
Oh, it's going to be very exciting. And I do want to dive back a little bit too, just before we go, because again, this program is called Your Space Journey. And we talked about your career a little bit, but being involved in a mission like this, I just have to feel that there's a passion for space that started somewhere along for you. I was just wondering, where did your passion for space exploration and engineering come from?
Oh, well, I grew up in, well, first of all, I was born in 1969. So I'm a child of the space age, right? I was born the year
Me
we
too.
landed on the moon.
Nice.
And I grew up in Alabama. So I got to visit the Huntsville Space and Rocket Center at various times when I was growing up. And I was good at math and science in high school. But to be honest, I didn't really know what engineering was until I went to college. Because I just kind of knew engineering was this thing, but I thought I might be a physicist or something like that. And then I learned that engineers get to go and build all this cool stuff. And when I was selecting a major my sophomore year, I decided to try aerospace because I thought it was really cool and really challenging. And I've been lucky enough to be able to stay working in the field. It's an amazing thing. I'm from that Star Trek, Star Wars generation, the original series, and I've managed to be lucky enough to be able to work in the field ever since.
I did just pinch yourself when you walk in the office sometimes and say, I can't believe I have this job. That's incredible.
Oh, yeah, no, absolutely. I mean, we get to create at JPL for NASA here, we get to create space missions. And there are really very few places that you can just like come up with an idea on the whiteboard and turn it into a deep space mission that's going out to the asteroid belt, right? That's a rare privilege to get to do that.
Oh, I could not imagine. Well, that's exciting. I appreciate you sharing your story with that. Now let's go back to Psyche. So what, again, the main objectives of the mission are to study Psyche. How?
What we're trying to do really is figure out where Psyche came from and how it exists. Because Psyche is a unique body. There really are no other metal asteroids that are anywhere near this size and uniformity in the solar system. And that's weird because there are thousands of asteroids. How can you end up with one big metal one? One of the theories that our principal investigator has is that Psyche may have once been inside of a forming baby planet. Now, all planets like the Earth and Mars and Jupiter have metal cores inside of them, and they form with these metal cores. And so the theory here is that this was a forming planet that formed a metal core, and then it collided with other bodies that ended up stripping off the rock that's on top of the planet and leaving just a piece of that core behind. Wow. And if that's true, if we can show that's true, then we can learn about how planets were created, but also about the interior of our own Earth, because we can't get to the Earth's core. It's under thousands of miles of rock. But maybe out here, floating in space, is a piece of a planetary core we can actually study directly.
That's amazing. And I understand that Psyche is about 3 times the distance from the sun that the Earth is. Is that right?
That's right. That's right. Right at the outer edge of the asteroid belt, which lies between the orbits of Mars and Jupiter.
Wow. Well, what is really interesting to me, too, is sort of the propulsion technology that Psyche is going to use to get to the asteroid Psyche. So Psyche, the name of the mission, and going to the asteroid Psyche. You're using solar propulsion. I believe it's the Hall effect thrusters. Is that correct? Can you tell us just more about that?
Yes, we're using a propulsion system. Overall, it's called solar electric propulsion. Mm-hmm. It's a form of advanced plasma propulsion where we take energy from the sun and we use it to ionize a neutral gas, in this case xenon, and then drive it through an electric field to accelerate it out to very, very high speeds. And what this does is it allows us to propel ourselves through space using a rocket that is powered by the sun instead of being powered by chemicals. And as a result, we can make a rocket that is way, way more efficient than the normal rockets that you see on Earth, the normal rockets that you envision with all the flames and all of that. Right. It's 5 times more efficient than that. And that's really enabling for this mission because we got to go a very long way and then get into orbit around this asteroid. And we do that using a combination of xenon and electrical power from the sun.
And that's incredible too, because I imagine, is this sort of like a constant acceleration as it's going through space?
It is. It's because these electric rockets, just because of the amount of power we have available, don't generate that much thrust. The peak thrust out of our rocket engine, our Hall effect rocket, is 250 millinewtons, which is about the weight of 3/4. You can imagine stacking 3/4 on your hand, right? And that weight that you feel is the thrust that's on the rocket. So it's not very much, but you apply it over the course of years and your spacecraft ends up going very, very fast. And it uses way, way less propellant than a chemical rocket, and just getting propellant into space is so expensive. That's what makes it worth doing this. It's being used this advanced propulsion technology.
Wow, that's truly amazing. What other kind of instruments are going to be on the Psyche spacecraft to study the asteroid?
Well, the spacecraft has a scientific payload that consists of a magnetometer to measure magnetic fields and an imager to take pictures of the asteroid, and something called a gamma ray neutron spectrometer, which will allow us to measure the elemental composition of the asteroid, but do it from space. So we never have to land on the asteroid. And the magnetometer in particular, if we get there and we detect a magnetic field, that's a good sign that Psyche was once inside of a forming planet, because where magnetic fields come from in planetary space is from the metal cores. And that's why the Earth has a magnetic field that we can use for compasses and stuff like that. It's from deep within the planet itself.
Wow. Now, you mentioned too that the expected launch date, 70 days roughly from the time of this recording. Can you tell us how long will it take Psyche to get to the asteroid, and then how long will the mission last?
Well, our launch period opens on October 5th. And once we're in space, it will take about 5.9 years in order to get to Psyche. And then once it's there, we'll get into orbit around it, and we'll spend another 2 years, 26 months doing our scientific studies of it. So you can consider it an 8-year mission end to end.
Wow, that's incredible. Now, I do want to ask this because, again, we have the science objectives, and there's so much to learn from this. But what personally excites you the most about this mission?
Well, I just think it's great to be able to fly a mission of true exploration, where we're going out and we're visiting something which has never been visited before. I mean, when we went to visit Mars the first time, like, scientists had all these ideas of what it might look like, and then they got there and they discovered it looked really different. Or people may remember this with New Horizons and Pluto. The scientists had this idea that it was kind of going to be this like very plain body, right, kind of a uniform ice ball. And then you see the pictures from it, and it's full of all these crevasses and all these different features on the surface. It's never what we expect the first time we go to visit something. And I expect no different from Psyche. I think we will go and we will see something that's beyond what we can imagine. And I think that's exciting to be able to go and explore like that and actually see new things, right? The true mission of exploration. Absolutely.
And you can always count on the unexpected, which brings me to my next question. You've been working on this project for 10 years. Obviously, it can't all be smooth sailing. What are some of the biggest challenges you and your team have faced for this mission?
Oh, well, I mean, when we proposed the mission, we had no idea there'd be a global pandemic in the middle of it. That was incredibly challenging, because we all had to go home. I had to work from home for over a year. And we're still trying to design and build a spacecraft. There were small teams of people that could go in and do the actual touch labor, but the rest of us, we're trying to coordinate the design of the system via these Zoom meetings. And, as we saw at the beginning of our Zoom meeting doesn't always work as expected. We were all learning along with everybody else how to do this remote work thing, how to collaborate remotely, how to communicate remotely. And that was hard. I'll say. And I still don't think we work as efficiently as we did quite in the pre-pandemic level, but we're getting back up there, right? It's been a tough time and a tough learning curve for everybody.
That is true. It definitely put all the teams through the ringers on this one. So your team's coming out ahead. Again, we're approaching the finish line, which I'm so excited about. You mentioned, we talked about the Hall thrusters. You mentioned some of the payload. Are there any other sort of new technologies that are being used in this mission that you haven't used before?
Well, first, I'll mention that this is going to be the first mission to use these Hall effect thrusters beyond the Earth-Moon system. We're the first people to go planetary with them. And I think that's a big milestone in the development of electric propulsion and Hall thruster technology. We've had other missions that have gone interplanetary, but they all used a different type of technology, gridded ion. We're the first to use this Hall thruster technology, and I'm proud of that. The other thing we have on the spacecraft is we have a technology demonstration payload, a deep space optical communication payload. And it's going to use lasers to be able to transmit data from very long distances out to Mars and beyond back to Earth. And this is the technology which will allow us someday to be able to transmit high definition video from the surface of Mars all the way back to Earth, allow astronauts to do that kind of thing. Wow. So it's an exciting new set of developments.
Oh, that is exciting. Now, I do want to kind of wrap this up. I have a question for you. It's amazing, again, what you do and your team. JPL's beautiful facility. My wife and I went there a few years ago, and we're just amazed at it. You can just feel the creativity and the engineering throughout it. There are some listeners out there. We get hear from kids that are listening. We hear young adults that are going to college and ready to make in this field. What advice? I think you're very successful in this field. What advice would you offer those who want to pursue a career in, say, engineering in the space industry or just engineering in general? What advice would you offer?
Well, there's a lot of advice to offer. The first thing I'll say is not everybody knows what they want to do when they're 16 or 17 years old or deciding where to go to college. I mean, I remember when I went to college, like meeting people who are mechanical engineering majors and going, what do mechanical engineers build? And the answer is everything. But I had no idea that that was true, right? So part of it is if you're young and you're considering what to do and you don't know what to do, and I think many people don't, and you have any interest in a technical field, take the most technical path that you can take. You know, if you can do physics or math or engineering. If you don't know what you want to do and you have some aptitude for that, because you can always later in your career go to something which is less technical. You can take a physics degree and become an engineer. You can take an engineering degree and become a lawyer or a doctor or an actor. I mean, I know people who've done all of these things, right? It's way harder to go the other way. So if you don't know what you want to do and you like technical things, like do technical stuff, take a technical degree, and it will open up options for you in the rest of your career. You can't go wrong with that these days.
Excellent, David. That's great advice. I just, again, want to thank you so much for your time today. I want to congratulate you and your team. We'll be watching this mission closely. Are you going to actually go to the launch? Just asking.
I am planning to be in Florida to watch this thing launch. It's going to be on a Falcon Heavy, and we got 2 boosters coming back. So we get to see the boosters land as well as the spacecraft go up.
That is a fantastic sight. Have you seen a Falcon Heavy go up with the 2 boosters landing before?
I have seen a Falcon Heavy go up and the boosters come back. It's incredible.
Me too. It is incredible. It is incredible. Hopefully, maybe I'll see you there. But David, again, I want to thank you so much for your time today, and best of luck to you and your team with this mission.
Okay, thank you, Chuck. It's a pleasure.
Your space journey.
Well, I really enjoyed my interview today with David O, and I'm excited about the upcoming Psyche mission. If you'd like to learn more, just go to nasa.gov/Psyche. I want to thank David for joining me today. I want to thank you for joining me as well. If you can do me a small favor and share this episode with a friend, I'd certainly appreciate it. Thanks so much for joining me today. We'll see you next time. God bless.